Okay, this is Algebra 2, Year 2, 11.8 homework. And we're doing the first three problems, and we're using Pascal's triangle to solve these. So number one is x plus y to the 8th. So if we look at Pascal's triangle at the 8th row, because remember that the row that you're looking at is the power you're taking your binomial to. So the numbers for our coefficients from Pascal's triangle in the 8th row are 1, 8, 28, 56, 70, 56, 28, 8, and 1. So those are the coefficients that we're going to use when we're writing out our terms. So for our first term, we're going to have this coefficient. So we have 1 times our first term. And our first term is going to be to the 8th, because remember we start with our power, and this term decreases by 1 each term. And then we have y, and y starts out with an exponent of 0, and this exponent will increase by 1 each term. So this is our first term. Then we'll add our second term. The coefficient is 8. Then we have x to the 7th because it's decreased by 1. And then we have y to the 1st because we're increasing by 1. And remember, your exponents should equal the power that you're raising your binomial to. So our third term, start out with your coefficient of 28, x to the 6th, y squared, plus 56 is our next coefficient, x to the 5th, y cubed, plus our next coefficient, which is 70, x to the 4th, y to the 4th, plus our next term, our coefficient is 56, x to the 3rd, y to the 5th, plus our next term is 28 is our coefficient, x squared, y to the 6th,
Jeez, God.
plus our next term is 8 for our coefficient, x to the 1, y to the 7th, and then our last term, our coefficient is 1, x to the 0, y to the 8th. So that's our expansion. And then we're just going to simplify a few things. So we have 1 times x to the 8th times y to the 0. Y to the 0 equals 1. Anything to the 0 is 1. So we have 1 times 1 times x to the 8th. So that's just x to the 8th. And then our next term we have 8x to the 7th, y to the 1. So y to the 1 is just y. So we can write that as 8x to the 7th y, plus our next term is already simplified as far as we can simplify it. Plus our next term, which is already simplified. Plus our next term, which is already simplified. Plus our next term. Plus our next term. And now our second to last term, we have 8x to the 1, y to the 7th. So again, x to the 1 is just x. So we can write this as 8x, y to the 7th. And then our last term is 1 times x to the 0 times y to the 8th. So again, x to the 0 is just 1. So you have 1 times y to the 8th. So that's just plus y to the 8th. So our simplified and expanded binomial is here. And they do get long. So, number 2.
You go back up for a second.
Uh-huh.
Alright.
You good?
Yeah.
So number 2. Number 2 is y plus 3 to the 6th. So we're going to look at Pascal's triangle at the 6th row to find our coefficients. And our coefficients from the 6th row are 1, 6, 15, 20, 15, 6, and 1. So just like in the last problem, we're going to take our first coefficient and multiply by our first term, which is y, and that is to the 6th. And then multiplied by our second term, which is 3, and that will be to the 0. And then we add our next term, which starts out with a coefficient of 6, times y to the 5th, because we're decreasing our exponents, times by 3, which is our second term, to the 1st, because we're increasing our exponents. Then plus our next coefficient, which is 15, times y to the 4th, 3 squared, plus our next term, which is 20 times y to the 3rd, 3 to the 3rd, plus our next coefficient, which is 15 times y squared, 3 to the 4th, plus our next coefficient, which is 6 times y to the 1, 3 to the 5th, plus our last coefficient, which is 1 times y to the 0, 3 to the 6th. So now this one, we're going to simplify our expansion. So for our first term, we have 1 times y to the 6th times 3 to the 0. 3 to the 0 again is just 1. It's important to remember that anything to the 0 power is 1. So we have 1 times y to the 6th, which just equals y to the 6th. And then our next term, we have 6 times y to the 5th times 3 to the 1. 3 to the first power is just 3 times 6 is 18. So we have 18 times y to the 5th. Our next one is 15y to the 4th, 3 squared. So we have 3 squared is 9 times 15 gives us 135, and then still multiplied by the y to the 4th. Plus our next term, which is 20 times y cubed times 3 cubed. 3 cubed is 27 times 20 gives us 540 y cubed. Plus our next term is 3 to the 4th times 15, which gives us 1215, so 1,215 y squared. Plus our next term is 3 to the 5th times 6, which gives us 1,458 times y to the 1, which is just y. And then our last term, 1 times y to the 0 times 3 to the 6. So we have 1 times y to the 0, which is 1, so 1 times 1 times 3 to the 6th, which is 729. So that is our expanded and simplified expansion of y plus 3 to the 6th. And our final problem, number 3. Number 3 is a subtraction problem, which I didn't cover in class, but what happens with the subtraction problem is your signs will alternate, or your addition and subtraction signs will alternate in the expansion. So I'll show you that when we expand it. So first we want to look at the 7th row of Pascal's triangle so that we can get our coefficients, which are 1, 7, 21, 35, 35, 21, 7, and 1. So we're going to start out just like we did before, that we take our first coefficient multiplied by the first term to our power, so x to the 7th, and then we have 6 to the 7th, and then now instead of adding, because we have a subtraction sign, this is going to become a negative. And we're going to have our next coefficient times x to the 6th. I'm sorry, our 6 should be to the 0 on our first one because we start with 0 and increase. So our first term is 1 times x to the 7th, 6 to the 0. Our second term is minus 7 times x to the 6th, 6 to the 1. And then now we subtracted, so now we're going to add. So this becomes times 21 our first term, which is x to the fifth times 6 squared. And then subtract 35 x to the fourth 6 cubed plus 35 x cubed 6 to the fourth minus 21 x squared 6 to the fifth plus 7 x to the 1 6 to the sixth and then minus 1 x to the 0 6 to the seventh. So now simplifying our expanded version, we have 1 times x to the seventh times 6 to the 0. So 6 to the 0 is 1, so 1 times 1 times x to the seventh is just x to the seventh. And then bring down your minus. 7 times 6 to the 1, which is just 6 times 7, is 42. X to the sixth. Bring down your addition. You have 6 squared, which is 36, times 21, which is 756, times by your x to the fifth. Bring down your minus. You have 6 cubed times 35, which is 7,560 times x to the fourth. Bring down your addition. Now you have 6 to the fourth times 35, which is 45,360 x cubed. Bring down your subtraction sign. You have 21 times 6 to the fifth, which is 16, 32, 96. And that's x squared. Bring down your addition sign. You have 6 to the sixth times 7. So that's 18, 66, 24. And that's x to the first, so that's just x. And then our last term is 1 times x to the 0, which is 1 times 1, times 6 to the 7th power. And 6 to the 7th power is 27, 99, 36. And that is the simplified expanded version of x minus 6 to the 7th. And we're done.